Have you ever sat on a runway, felt those engines just roar to life, and as this massive metal machine hurtles into the sky, you just think, how? Seriously, how is this possible? It feels like it's breaking the most basic rule of nature, right? Well, today we're going to pull back that curtain and really get into the physics of flight.
And you know, the answer doesn't start in some super complicated textbook. Nope. It actually starts with a really simple feeling, something you've probably done 100 times without even giving it a second thought.
Okay, picture this with me. You're driving along, you stick your hand out the window, and you feel the wind pushing against your palm, right? You can tilt your hand up and feel it lift, or tilt it down and feel it get showed down. That feeling, that very real force, that is air. And understanding that feeling, well, that's the very first step to understanding how a giant airplane flies. So that push you feel, that's just one piece of a really delicate puzzle. You see, any object that's flying, I don't care if it's a paper airplane or a massive jumbo jet, is constantly being pushed and pulled by four fundamental forces. Mastering this invisible dance is the absolute secret to staying in the air.
First up, the most obvious one, weight. This is just gravity doing its thing, you know? Pulling the plane and everything inside it, including you, straight down toward the ground. It's the big challenge we have to overcome.
And its direct rival is lift. This is the awesome upward force that the wings create. It's what actually pushes the plane up into the sky. And for a plane to even get off the ground, lift has to be stronger than weight. This is the force we're really going to dig into in just a minute. Of course, a plane can't just sit still and generate lift. It has to be moving, and moving fast. That's where thrust comes in. It's that powerful forward push from the engines, just blasting the airplane through the air. Remember your hand out in the car window? As the plane barrels forward, the air pushes back against it. That resistance has a name, drag. It's basically air friction, and it's always trying to slow the plane down. It's the natural enemy of thrust. So we've got our four key players in this high-stakes game. But let's be real, the one that blows our minds, the one that feels like actual magic, is lift. So how in the world does a relatively thin wing create enough force to pick up a 400-ton machine? Well, it's not just one thing. The answer is actually this brilliant partnership between two different principles of physics, and they both work together on the wing's special design. It all boils down to the clever design of the wing, both its funny curved shape and the way it's tilted into the wind. So let's break both of those down one by one. Okay, so the first part of the secret is the wing's shape. It's not flat, it's curved on the top and much flatter on the bottom. Because of that curve, the air that flows over the top has to travel a longer way to get to the back of the wing, so it has to speed up. Now, a famous idea in physics called Bernoulli's principle tells us that faster-moving air has lower pressure. So what you get is low pressure on top of the wing and higher pressure underneath it. That difference in pressure creates a real physical push from below. The wing is literally being pushed up. But wait, that's only half the story. The other huge factor is the wing's angle. It doesn't just cut through the air perfectly flat. It's tilted up just a little bit. We call this the angle of attack. As the wing moves forward, this angle acts like a ramp, forcing a massive amount of air downwards. And as Isaac Newton famously told us, for every action there's an equal and opposite reaction. So by pushing all that air down, the air pushes the wing up. Simple as that, and incredibly powerful. Okay, so we've got lift figured out, we've conquered gravity, but what about actually going somewhere? This brings us back to our horizontal forces, to that constant tug-of-war between the engines pushing forward and the air pushing back. And this is a constant balancing act. It's really simple. To speed up, the engines have to create more thrust than the backward pull of drag. To fly at one steady speed, thrust and drag have to be perfectly equal. The catch is, the faster you fly, the harder the air pushes back, the more drag you create. So the engines have to work even harder just to maintain that speed. So knowing about these four forces is one thing, but how do pilots actually use them to climb, to turn, to do anything? Well, this is where the pilot steps in and becomes, well, kind of like a physicist in the driver's seat. Yeah, they aren't just pointing the plane's nose where they want to go. They're actively, constantly manipulating these invisible forces. They're fine-tuning the balance of lift, weight, thrust, and drag to guide this huge aircraft with incredible precision. And this is their toolkit. See these moving parts on the wings and the tail? By moving the ailerons out on the wings, a pilot can make one wing lift more than the other, causing the whole plane to roll or bank into a turn. The elevator on the tail?
That moves up and down to pitch the plane's nose up for a climb or down for a descent. And the rudder on that big vertical fin, that steers the nose left and right. We call that yaw.
So when you put this all together, you start to see that flight isn't really about brute force. It's all about achieving this perfect, delicate state of balance.
And this is the key takeaway. When a plane is just cruising along nice and smooth, lift is perfectly balancing out weight, and thrust is perfectly balancing out drag. Everything is in harmony. The real art of flying, the skill of a pilot, is to carefully and precisely unbalance these forces, just for a second, to make the plane do something new, before finding that perfect equilibrium all over again.
So in the end, an airplane isn't defying physics at all. It's the exact opposite. It's about understanding physics so incredibly well that you can make it do exactly what you want. The airplane doesn't fight gravity. It commands it by mastering the forces of the air all around it.
It's just an absolutely incredible achievement when you think about it. And it kind of makes you wonder, now that we've got this down and we're looking at things like hypersonic travel or all-electric jets, what new balances are we going to have to master next? What's the next frontier?